Hi, thanks for joining me. So today I'd like to talk about my adventure here dumping a script for City Hunter on the PC engine, also known as the TurboGrafx-16 in North America at any rate. So we can see here we've got this relatively big text. It's probably 16 by 16, could be something else. These I think are like scenarios or something like that. So we pick one and we get a whole bunch of text here. And this actually ended up being super useful for what you're going to see ends up coming up here pretty soon. Now the main issue with this right off is that there's a bunch of kanji in here. Kanji is gonna make your table file way bigger, and the easiest thing to do is going to be to see all of that kanji in the order that it shows up in the table file. So we're gonna open this up and we're going to look through this. Now it automatically defaults to a 4 bits per pixel, which is the color depth. We've talked about that before, and this is sort of defaulting to 16 by 16 as a way of representing this. I'd say this looks font-like, but it's all jumbled up. So I'm going to fast forward for you guys so you don't have to go through this whole process with me. Probably the best is this 2 bits per pixel for the sort of like the way things tend to be stored for the Game Boy. You can almost see the font here, but again, you know, you'd have to get it to maybe like 16 by 16. I mean, you can almost make out like 8 and 9 there, which is it's encouraging, but where's 0 through 7? You know, I mean, it's stored. You know, it's compressed, or it's stored in some way that at the very least we can't dig into it with this particular tile viewer. So say you can't see a font and your game does have a bunch of kanji. That's a problem, and I was able to get around this problem, so I wanted to let you guys know what I did, so maybe you guys could get around this problem, or maybe you'll just find it interesting. I'd run into this issue with another game called World Derby on the Game Gear, and I haven't fixed the problem for that yet, but I decided when I went to SMS Power, and Maxim gave me a hand there, and apologies to Maxim somewhat. I was a little passive-aggressive when they had suggested this to me, but his suggestion was basically that I wanted to insert the values into the ROM so that I can see the font come up in the ROM and figure out what the kanji is that way. And that's what I'm going to do here for City Hunter. So how are we going to do this? Well, we're going to go here and we're going to write a PHP script. So we go over here, I make a new PHP script, and I'm not going to, we're just going to step through this. I'm not going to like retype this out for you guys. So for starters, again, and this could have been a variable, it doesn't matter, but anyway, I just made a constant ROM, and it's going to be our path to our ROM. So I've gotten my stuff and my translations, my on-hold City Hunter project, and I obviously renamed the ROM to City Hunter, ch_edit PCE. So I have something that's completely different. And we have these offsets. Now, how did I find these offsets? So if we go back into our ROM here, we're going to go ahead and let's look at that text that we had come up. Alright, so we can pause this just by clicking out of this. Let's find a string of something that is going to make sense for us to search for. And so down here we have dewa nai kato moi. So I decided let's just start with that, and I skipped the de. When we put in, basically here 46, 41, 2E, 3240, and we search for that, we don't get anything. So I said, okay. So what I'm going to do is add this, skip this, 41, skip value, 2E, skip value. And if you're wondering where I got these values from, look at my other video on dumping a script and making a table file. And skip value, 2E back in there, add value, skip value, and we'll just do these first 4. Add value, and we'll scan, and look, that comes up. So this is kind of what I was expecting anyway, because we have all this kanji. Chances are this is going to be dual-byte encoded, and that's how I'm pretty sure that's how any encoding that uses lots of characters is going to be. I think even Unicode only uses 2 bytes for its encoding, and I could be wrong about that, but I don't think that I am, because that should give you a lot. Maybe I'm wrong. I don't know. But anyway, so in this case it gives us plenty of values to work with. And what we can see is we have something along the lines of 1900, 1400, 1000, and 5000. So we're going to take 19 and wa. We're going to go over to our table helper, which I did a video about. Put in 19, and we're going to put in our wa. Just confirming that it was 19. And we'll save that. And we'll go over here, and we will run it. Okay, so we see this is what we get. And let's say I put that in here. So we basically have, starting off, our very first byte here at 0, 0 is our ah. That's like A in English. And yeah, this is the start of our table file. Okay, so City Hunter, and we're going to open our new table file. And our table file is temp table. Okay, and we need to view it as Unicode, and we're going to actually we're just going to jump to our spot here. So this is E34C. So let's search to E34C and go. So this is it, and we can see here we've got, you know, wa, na, e, ka, to. Now what we want to know is, do we have the rest of this stuff right? So let's take a look again at our text here. So what we expect to see is, what is this? De wa na I ka to omo I. So we should see, after omo we should see an E. So de wa na I ka to, here's omo, here's I. Alright, so that looks good. So we can start filling some of these out based on this. You know, we can put this kanji in here as EA00. But we can't really do that for all of these kanji. We can do it for all of the kanji that we see here in this chunk of text, but that's not necessarily all the kanji in the game. We have to get at this kanji somehow and see what all of these values would be. What we need to do then is, based on these values, we have to insert. And what I decided to do, of course, is insert into this block of text here all of this stuff. It goes from E200 to E3BB. So that's our start and end offset. So I go ahead and put that in here, and we're going to get our length. That's, of course, going to be our end offset minus our start offset. So there we go. This is what we're dealing with. Now we have to go ahead and open our ROM. So we're going to say file open ROM. And we give it some parameters. If you want to open it for read and write, read is R, and read and write is R+. So we're opening this R+. We move the pointer to the starting offset, and that's something I did in this other code here. We're just going to use fseek for that. So we pass it this what we've opened, and you know, it has a pointer associated with it. And so we move the pointer to this start offset, and that works. It's just in regular hex notation, and it gets that. So that's good. So then we're going to go ahead and read the contents. So we basically give it the handle, and then we give it the length. So that gives us our contents. So once we have the contents, this is binary, so it's going to be a whole bunch of ones and zeros. So I'm going to unpack it, and I'm going to use this argument. It's H star, and I kind of forget what the star is, but H is like, it's hexadecimal basically. There's 2 different ones you can use on whether like the which nibble is high or low or something like that. But anyway, so yeah, we unpack it into hex, and it seems like it must give us an array, and I don't know, the 0 element of that array is something else. So I guess the 1 element is actually like the contents that we care about. So I just make it uppercase because that's what how I'm used to seeing hex values. You don't have to do that. So I do that, and I've still got all my testing junk in here. So I basically, and I var dump it. We'll var dump it to the screen. You guys can see it. So you can follow along with what I was seeing. Here it is. This is the information that we pulled, B900 CD00. And if we go back and look at our ROM, we can see it's B900 CD00, you know, CE00. and that stuff. So this is definitely what we want. So let's go ahead and go back here, and we will do that. So okay, so we've read this, but I mean I've already read information from ROMs before. What I want to do is do some insertion. I find that there's this pack function, and we're going to want to use that. So pack also has similar arguments to whatever this was, unpack, which makes sense. So I decided to go ahead and just use the same notation. We're going to do hex, whatever that is, and I actually just try out some, like a string. Okay, so because our you know, this is basically 2-byte encoding, and it's gonna be 4 characters here: 0000, 0001, 0002, and 0003 is what I decided to put in. I confirm that I can pack this binary data, and I have to seek back to the start offset, which I didn't realize at first, and then I can go ahead and write that in there to this handle, put this binary data in there, and I print written. So let's go ahead. I'll show that to you so that you guys can see what that was like, and we'll go ahead and run it. So this is our script. We run it. It is written. And then we're going to go here, and we're going to file open our edited file, and then we're going to jump to E200. We see 0, 0, 0, 1, 0, 2, 0, 3. Okay, just like I had done over here. So that was very successful, and I was very excited when I did that. Now, so then the trick was making this binary data be the stuff that we actually want it to be, and that isn't very hard. What we start with originally is 0, because that's where our table file starts. Our temp table here is 00 is ah. So we start off with 0, and I do this in hex notation. Our hex, we're basically define a hex string that doesn't have anything in it to start off with, a null hex string. And then we're going to do a for loop. So we're going to do for, you know, x equals 0 while x is less than the half the length minus 1. We're going to, and then we're going to increment it. And basically all that means, originally I just had length in here, but what I realized is because this is dual-byte encoding, if I just do it by length, it's twice as big as it needs to be. So I cut it in half. And then I just subtract 1 because I decided that I wanted to leave this this trailing question mark there, because that's just sort of a nice endpoint, so that I can see, okay, all this stuff is stuff I inserted, and then it ends in this question mark. So that was just convenient. So so we're gonna generate a value, and that value is based on this. So originally it's going to be 0, and that, you know, as we iterate through this, and we're going to pad it. So we're going to convert our hex value to decimal. This is our start value, and then we're going to pad it to 2 spaces with a 0 on the left. And also all that's going to do, like for instance, the first time it's going to take our 0 and it's going to make it 0, 0. Okay. Then we're going to get our value, and our value is going to be 0, 0, and we're going to append to it. Actually the first time what we're going to do is append to it 0, 0, because that's what we found was what our stuff is padded with here, 0, 0, 0, 0, 0, 0. So so let's you know, we'll do that. So then we get through this line, we end up with 0, 0, 0, 0. So that is our value is going to get appended to hex string. Hex string was nothing, so our hex string to start off with is 0, 0, 0, 0, and then we increment. So you know how this goes. You know, the next time it's going to be 1, and we're going to end up with that with 2 zeros appended to it, and so on and so on. So let's see what that looks like. So we can see now we have 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, all the way through, and we will go ahead and open this up. And yay, we did it. Okay, so what's nice about this, and this isn't showing us anything we couldn't already figure out just by doing our relative searching. But the part that's tough is, and then you get down to this kanji, because the kanji isn't in any particular or alphabetical order, and we just don't know what it all is. The reason why we included the basically the start value is because now we need to take that last value. So we go here, E3BB. So we're going to go ahead and go to offset E3BB. This is going to make a lot more sense. Okay, so yeah, so 96 is our question mark, FFFF is our like end point, and we basically got up to DC. So we got through D8, D9, D8, DB, and DC. So we're going to go to DC, and we're going to put that in. So this is our new start point, and yay! So we basically got to the end of our 0, values we can use. So it's DC, DD, DE. We're all the way up here near F. So we get to FD00, FE00, FF00, and then that's it. We start over again from the beginning. So we're going to go ahead and put in 01. That's going to be our new suffix. And I have no idea, you know, how many new values this is going to make. So we're going to go ahead and save that, and we'll write it, and we'll bring it up again. And just FYI, what we get is this. Okay, a whole bunch more kanji. We had all of this kanji and all of this kanji. So there's basically two whole like banks. Basically two whole, I don't know if they're banks, but they're like 256 values. You had one like 256 that included all the kana characters and all that punctuation and all that other stuff, but then you had like one full set of 256 that essentially that was all these kanji. Let's go ahead and open up our actual table file, and you can see here, now this took me, you know, quite a while because it's hundreds of values. This is our kana, and then we get into the kanji. So it just goes on and on and on and on and on. There was a little bit of trouble still. We're not in the clear. So I went ahead and I dumped these scripts. Dump text, file edit. So let me do temp. What was that? That's the second one, I guess, technically. So we're going to do temp text. And we're going to go over here. So on City Hunter, we have temp text 2. Oakley dokley. So this is what we get, and I'm like, okay, so what are these? Well, what these values are is they're control codes. You know, let's just try doing this. Okay, so this should look pretty much like our script looks, and let's confirm whether or not that is the case. So we get this, blah 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 blah, the sub brain system or something like that. Boudin, yeah. Oh wait, yeah, so subbrain system you know, a person's brain can, what is this, synchronize and blah blah blah. So yeah, so blah blah shite, so that's right there. So this is this next part, blah 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 blah, right up to computer. Is that yeah, computer da. There's a space. We get here, shikashi, blah 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 blah. Okay, so yeah, so we basically get to the end of that. It goes to 11, and I mean, maybe that's like I don't know, it just triggers a pointer and it goes somewhere else and pulls some other text. It's actually not the text that comes next in the script. It's that, and then we get, actually that's not the text that comes next in the script either, I don't think. But this is. So then we get Tanomu, blah 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 blah, 13. So we can see that basically that is working, and then this. So basically that's working the way that I expect, except that it's not quite. This isn't the full story, it's really close. So you know, this is totally translatable as it is, so that's good. But we run into a special condition, and that's these 0 zeros. So the best way I can explain this is that it's an artifact of the way that they chose to use these control codes. So again, like I said, we have dual-byte encoding. They're using these single bytes as control codes that do something at the ends of these text lines. And when you get to one that is 0 0, the problem is that 0 0 is also our like our padding that's part of some of our text encoding. We have an extra value in here, and so it ends up rendering it as a character, and this 00 is actually associated with the next character. So what this next character is 0000. It's ah. It's our very first character in our table. It's this one. So what we have to do here is we basically have to find what Su is, and in this case Su is OC. It's actually OCOO, but this OO in this case is actually part of this encoding. So what we need to do is get rid of this Su, because that's the wrong thing. The right thing is this control code, which is OC, and then the right thing here is 2 sets of zeros, which is ah. So we're going to put ah in there, so that becomes ade. So so that was a problem, and that's not actually even the only issue. We also have an issue with the O1s, because when there's a control code and it's followed by an O1, there are times when the sentence starts with this character E, and that is also an issue. That isn't even the whole story. This is something very specific to City Hunter, but I thought that you guys might get a kick out of this. There's a character in the table file that I could not find. So we'll go ahead and open the real table, and we'll go down here, and it's this character. Now this is not the right character. The right character, we will go ahead and show you here, is this. Now this radical, it's actually like a permutation of dog, I believe, but it stands for like beast, animal, something along those lines. And that's not what this is. This is water. Is the radical that's on the left hand side of this character, and that is because I could not find this kanji character with this radical next to it in here. And basically the trouble is that this particular word processor, I guess it basically it doesn't actually display the full Unicode set. It pretty much displays the JIS set, like you would find in Shift JIS encoding. And the very interesting part is, if you go to Wikipedia, now this is City Hunter's name, Saeba Ryo, and Ryo is written with this character. So what it'll say is the name is written like this. This is not listed in JIS 0208 of Japan. It cannot be displayed accurately depending on the environment. For this reason, there are cases where the name is written in pseudonym notation. So like in this case, it's written just out in kana, in Ryo, and it's also sometimes written like this, which is basically that, you know, kanji character without its radical at all. So so this was a problem for me because I want to represent this accurately. So yeah, so what I ended up having to do is copy paste, just do a search and replace for that kanji into these scripts where it appears, which it appears in all of them because it's his name. And then I basically just saved them, like I pretty much used file save as, and when we saved this as, basically the default is, well, it's the default line terminator, it's UTF-8. So I basically just save it as UTF-8, which does have that kanji character in it, and we get our script dumps here. Script UTF-8, I basically just saved it as a separate file, you know, 2 UTF-8, 3 UTF-8, 4 UTF-8, and 5 somewhere. I don't have a 5 UTF, oh there it is, 5 UTF-8. And that's it, finally. So I wanted to share this with you guys just so that you could kind of see, start to finish, what it's like going through and, you know, finding one of these ROMs that has a whole ton of kanji in it and not being able to get at the font in some sort of a tile viewer or editor, because that's annoying. But there is something you can do, and the main thing for me is that writing this script to insert these values was quite a bit easier than I thought it was going to be. This is not rocket science. It's very basic. I mean, aside from just, I mean, yeah, you know, I had to look up pack, and you know, I had to do a couple of fiddly things here and there, but it was pretty simple. So so I wanted to share that with you guys because I thought that information might be useful. hope you enjoyed this, and I hope you'll join me again for more game hacking stuff as time goes by. Thanks for watching.